Welcome back. Today's problem involves pharmacoeconomics. And here's the problem. You're part of the pharmacy team at the community health clinic that's evaluating two new long-acting injectable antipsychotics for formulary inclusion. Drug A costs $12,000 per year and it results in an average of 0.85 QALY or quality adjusted life years. Drug B, on the other hand, costs $8,000 per year and results in 0.75 quality adjusted life years. Both drugs are safe and effective, but the clinic has limited resources and must justify costs based on ICER or incremental cost effectiveness. The question is, what is the ICER or incremental cost effectiveness ratio of drug A compared to drug B? Now, in order to do this problem, you need to know the equation for ICER. So essentially, ICER is, typically you put the drug that costs more first, and it, so we'll call this cost A for drug A, since that one was more expensive. And then you say minus cost of drug B. And you divide that, and in the denominator, you're going to have the outcomes that are linked to each drug. In this case, the outcome is reported as quality adjusted life year. So for drug A, you essentially put quality adjusted life year for drug A, and you subtract that for the same thing from drug B. So essentially you plug in, so drug A costs $12,000 per year. You subtracted the cost of the drug B, which was $8,000. And in the denominator, you had 0.85 minus 0.75. And that should give you 4,000 divided by 0.1, which equals 40,000. So 40,000, which is choice A, is the ICER for this, which essentially means that drug A costs $40,000 more per quality adjusted life year gained compared to drug B. Now, whether that's worth it depends on the clinic's willingness to pay this, and typically clinics have a threshold for, what ICER would be worth it for them based on the outcome that they are looking at. Now, speaking of quality adjusted life year, so a quality adjusted life year is a standard measure used in health economics to assess the value of medical interventions. It combines quantity of life, in other words, how long someone lives, with quality of life, and that's essentially how well they live. And it combines those two into a single metric. So essentially, you can think of, and I'm gonna use a different color, let's say green. So quality adjusted life year is essentially years of life multiplied by utility value. And so essentially a quality adjusted life year of 1, it means 1 year of life in perfect health. A quality adjusted life year of 0.5 means 1 year of life at 50% quality, such as due to illness or disability. And a quality adjusted life year of 0 essentially means death. Now you see this utility values, and utility value in this equation essentially is a score based on patient-reported outcomes or expert consensus, and it's different based on whatever disease state and what outcome you're looking at. So these numbers vary, and essentially a utility value is a number between it's a scale. So if you have a utility value of 1, This essentially means, perfect health. And then you get something between that and 0. So 0 essentially means death. So you can adjust it somewhere between 0 to 1. Essentially tells you that somebody's has some sort of disability or illness. And interestingly enough, this number could also be a negative number. So if it's a negative number, this essentially means worse than death. So, essentially the person wishes they were dead, based on how bad the quality of their life has become as a consequence of the disability or the illness that they have. Hopefully this problem did not change your personal utility value to a negative number. Make sure to like and subscribe. And until next time, take care.